Hi, my name is Darren. Me and my teammates are from DCS 50581213, and now we are going to do our operating system video assignment. Enjoy! We are from Team Saitama. There are three scheduling algorithms that we are going to do in this video is non-preemptive short job first, preemptive priority, and last non-preemptive priority. This is the process table that we have made, which have burst time, arrival time, priority. First, P1, it have 5 burst time, 3 arrival time, and 4 priority. P2, it has 7 burst time, 0 arrival time, and 2 priority. P3, 3 burst time, 8 arrival time, 3 priority. P4, 8 burst time, 7 arrival time, and 1 priority. And last, P5, it has 11 burst time, 4 arrival time, and 5 priority. After arrangement by using arrival time, P2 have the shortest arrival time to be the first process, and continue to the second shortest arrival time, which is P1 that have a 3 arrival time, and continue with 4 arrival time, 7 arrival time, and 8 arrival time. How to do non-preemptive short job first? First, arrange the process follow the smallest arrival time, and the smallest arrival time will do first. Second, focus on the burst time after arrange the arrival time and use burst time to add in the previous response time. As we can see, P2 have the shortest arrival time, which is 0, and follow up with P1 3 arrival time, P5 4 arrival time, P4 7 arrival time, and last P3 8 arrival time. And this is the Gantt chart that we have drawn. We start from the lowest arrival time, which is P2, P1, P5, P4, and P3. And we can start focus on the burst time. The burst time of P2 is 7, so we add it inside, then it becomes 7. And next is P1. We same focus on the burst time is 5, so we add 5 into 7, so it becomes 12. And next we need to start to see the lowest burst time, which is 3, and add it up and become 15, and follow up with 8 become 20, and 15 add 8 and become to 23, and add up the largest is 11, so it becomes 34. After finishing the Gantt chart, we proceed to the waiting time. Waiting time is the response time minus the arrival time. So the P1 response time is 7, and then we minus the arrival time of P1, that is 3, so it becomes 4. Then continues to P2 is just the same, response time minus arrival time, and P3, P4, P5. Next, average waiting time. Like we see, the total of this we need to add together and divide by 5. If there is 5 process, then we divide by 5. If there is 6 process, then we divide by 6. So we only have 5 process, so we divide by 5. And then 35 divided by 5, and it equals to 7 ms.
Hello everybody, today I want to explain about the preemptive priority. To do the preemptive priority, first you need to draw a Gantt chart, then you need to arrange the process follow the arrive time. The smaller arrive time of process will do first. Next, you need to focus on the priority. Scheduler will arrange the process following the priority from the smaller number to the highest number. This is our example questions. Before you draw a Gantt chart, you need to write down the arrival time and priority first. At the example above, we know that P2 arrival time is 0 seconds, so we start from P2 and we write down its priority, which is 2 behind the arrival time. The P1 is arrived at 3rd second, so we compare P1 and P2 and write down each priority under the columns. Now we know that the priority P2 is 2 and the priority P1 is 4. So we use the P2 first and we move to the next column. Then P5, which priority is 5, is arrived at the 4th second. We also compare P2, P1 and P5 to find the smallest priority and fill it on the column. As we note that the P2 is the smallest one, so we fill up and we write down the 7 on the right side of P2 because process of P2 is already done the burst time, and so on the P3. Then we also compare the smallest of priority and write down below the column. Lastly, we count out all the burst time of the process.
So CPU scheduling of non-preemptive priority. Our question is as shown as in the slide. So non-preemptive priority, when time is 0, P2 priority 2 is enter, then P2 enter the Gantt chart. So waiting list, P2 also enter waiting list. So time 3, P1 enter priority 4. Waiting list, the new waiting list is P2 priority 2 and P1 priority 4. Then T4, P5 enter priority 5. Then the new waiting list are P2 priority 2, next P1 priority 4, next P5 priority 5. When T7, P4 enter priority 1. So the new waiting list are P4 priority 1, P1 priority 4 and P5 priority 5. So P4 is priority 1, so P4 enter first. Then T8, P3 priority 3 enter. The new waiting list is P4 priority 1, P3 priority 3, P1 priority 4, P5 priority 5. Then T12, P4 setter, then P3 enter. With T20, P3 setter, then P1 priority 4 enter. Then time 23, P1 setter, the last is P5 priority 5. Then the ending time is 34. Thank you. So next is waiting time. Waiting time equals to starting time minus arrival time. So P1 starting time start at 12 and its arrival time is 3, so 20 minus 3 equals to 17. P2 start at 0, arrival time is 0, so 0 minus 0 equals to 0. Then process P3 start at 12, arrival time is 8, so 12 minus 8 equals to 4. Next is P4 start at 7, arrival time is 7, so 7 minus 7 equals to 0. Next is P5 start at 23, arrival time is 4, so 23 minus 4 equals to 19. Okay, next is average waiting time. Bracket 17 plus 0 plus 4 plus 0 plus 19 bracket divided by 5 equals to 40 divided by 5 equals to 8 ms. Thank you.
Thank you for watching.